Lester, Wushu Engineer. On my channel I've uploaded quite a few videos testing various kinds of stab and cut resistant armor over the years. Both commercially available cut and stab resistant products and DIY projects of my own. To this end, I built a weighted pendulum test rig for consistent impact energies and forces. It's one of the few instances on my channel where I will use a machine to swing a weapon, because in these cases specifically I'm not testing human wielded weapon performance, but the performance of the armor samples alone. So consistency is important here to ensure that samples can be tested under similar threat levels and conditions. The pendulum apparatus has been designed to impact against a heavy wooden block. This is approximately 12 kilograms in weight, that swings freely on a chain instead of impacting against a rigid mounting platform. Now, the reason that I've chosen to use a free swinging wooden block instead of a rigid platform to mount the armor samples on is that the human body does not react like a rigid platform when struck. We move when things impact with us. So the pendulum itself is weighted with a 5 kilogram weight and strikes with kinetic energy and impact force, as you'll see noted on the tables displayed on the screen right now. As you would expect, the pendulum also has a sharpened knife blade mounted on the front. The blade that I have chosen to standardize my tests with is the cold steel GI Tanto blade. The armor samples are mounted on a foam pad that simulates a soft, fleshy backing. Now, recently I got a few comments on my videos in which I was experimenting with using ultra-high molecular weight polyethylene felt as the basis for stab and cut resistant armor. I mentioned in my responses that I had since been experimenting with using stainless steel shim washers bonded to the ultra-high molecular weight polyethylene felt, and the commenter indicated that they would be interested in seeing the video. So I decided to complete the testing and upload the video, and that's why we're here right now. I'm not going to go into too much detail, well, I'm not going to go into any detail really on ultra-high molecular weight polyethylene felt. I've done that to death in my previous videos, so check them out for context. In actual fact, in one of those videos I actually took a little microscopic video file of what comparatively what various fabrics, including ultra-high molecular weight polyethylene felt, look like magnified. What I found was that in those previous videos during my tests, what I found was that ultra-high molecular weight polyethylene felt has a lot of potential for stab resistance, but it can't deliver on that potential alone, on its own. It would have to be combined with something else to create more of an integrated system in order to be effective. In some of these previous videos, I tried layering ultra-high molecular weight polyethylene felt with slippery fabric layers interspersed to allow layers to slip across each other and thus interfere with stabbing penetrations. I've also incorporated discs of composite plastic bonded onto the felt in past videos. These approaches have been more or less successful, but the added complexity and bulk associated with having rows of strips and multi-layered fabrics has actually been quite a strong deterrent to the development. If something becomes more complicated, if it becomes too complicated, it becomes unappealing. So the more complicated something becomes, the less appealing it becomes. There's always more potential for a complex system to fail than a simple one. The simple solution is often the best. Not to mention the cost in time and resources to manufacture and maintain more complex systems. Elegant simplicity is the goal that we strive for quite often in engineering. So I wanted to simplify the system more. But before I go into talking about my current stab resistant armor design, I feel that I must actually clarify something about making stab resistant armor. Resisting stabbing is hard. And there is a strong trade-off between practicality and stab resistance. You'll note here that I'm not actually even mentioning cut resistance. The reason is that making something resistant to being cut through a slash or just a sawing cut motion, it's orders of magnitude easier to do that than to resist stabbing penetration. In fact, even suitably thick, padded or layered clothing can offer sufficient resistance to cutting to act as a form of cut-resistant armor. So in my testing, I focus mainly on stabbing, because that's by far the most significant threat posed by knives and similar bladed weapons. Most people understand that there's no such thing as bulletproof armor, as in armor that will stop all ballistic threats. Ballistic armor is rated to stop various types of threats, and typically the higher rated ballistic protection systems are bulky, heavy, and they cover much reduced areas of the user's body. In fact, in some cases, really just a small rectangle, doesn't even cover the lower part of the abdomen. And even the best rated personal ballistic armor will not stop high enough threats, such as a 50 cal rifle for instance. A similar situation can occur with stab resistance. As a silly example to illustrate the point, mounting a high carbon steel stiletto blade onto the front of a rocket and firing it at just about any kind of armor will more than likely result in armor penetration. It's quite easy to build stab resistant armor that would completely stop all penetrations from a human wielded blade. In fact, I've tested such options on my channel before. For example, ceramic and fiberglass composites will literally break knife blades instead of allowing any kind of penetration to occur. However, armor designs like this will also be completely impractical to wear in normal day-to-day life due to the bulk, the weight, the obtrusiveness, and restriction of movement associated with this kind of armor. Remember that something that you might be quite happy to wear on some kind of medieval battlefield, for instance, is not necessarily something that you're going to want to wear on a day-to-day basis, which is often, unfortunately, the most likely setting to be randomly attacked and have to defend yourself against someone wielding a knife. So it will be of no real benefit if you're looking for a type of armor that can be worn regularly, but that is absolutely stab proof. It's no good having an amazing suit of armor sitting at home on a display stand when some punk with a knife gets the jump on you in a back alley somewhere.
Well, do you, punk?
So it's far better to develop practical armor designs that provide an acceptable, albeit imperfect or limited, level of protection, but that can be practically worn on a regular basis. Combining the imperfect but practical level of stab-resistant protection provided by a worn garment, along with effective combat training, defensive movement, and knife defense techniques, will certainly have a massive impact on a defender's chances of surviving a knife attack. And that brings us neatly to my current design. After considering my previous designs involving multiple layers of strips covered in composite discs, I decided to simplify things considerably, as I've already mentioned. I wanted to design the armor to incorporate either just a single or a double layer of ultra-high molecular weight polyethylene felt, along with some kind of rigid, flat elements interspersed to help resist stabbing penetration. Now, one of the big downers associated with incorporating hundreds of rigid, flat elements is manufacturing all those rigid, flat elements. The amount of work involved can increase exponentially, depending on the complexity of the shape that you choose. So for instance, manufacturing hundreds of hexagonal shapes to mimic, for instance, a traditional Japanese Kiko armor design, as I actually originally wanted to do, would be pretty much unachievable practically, given the time constraints, at least for me. So I looked around for other options and finally settled on buying a whole bunch of circular washers and basing the armor design around these, bonded onto ultra-high molecular weight polyethylene felt. This proved to be a bit of a pipe dream because, first of all, conventional steel washers of the right dimensions, because of their thickness, would just make the armor too heavy to be practical. What I wanted was, what I ended up wanting was 2mm thick G10 fiberglass washers. But getting those in bulk was far too expensive, even via Alibaba, due to the current global situation and increased shipping costs. Another consideration is that even the 2mm thick G10 fiberglass washers, though lighter than steel washers, would still add quite a bit of weight to the final design, as well as introducing weak points between the washers. Because I was not going to overlay the G10 washers in a scaled arrangement. So the junctions between the washers, so where they butt up against each other, would be potential armor penetration points. Finally, having rigid, flat elements of the scale of the washers I was considering would decrease the flexibility of the armor design to a point where it would start to look obtrusive, limit movement, and thus no longer be practical. It is at this point that I started to look at using metallic shim washers for the rigid elements. Now, shim washers come in a variety of thicknesses, but they're typically much thinner than conventional washers. So I ended up ordering a bunch of stainless steel shim washers, which I thought were going to be around 0.4mm thick. At least that was my plan. When they arrived, I realized I had made a fundamental error. And I had in fact ordered 0.1mm thick stainless steel shim washers. And this is what they look like. They're very thin, very flimsy, very light. This put an initial damper on things because these are a lot more fragile than I was hoping for. And it wasn't cheap to order these either, by the way. So I tried some impromptu manual stab tests with some of the washers just lying loose on some ultra-high molecular weight polyethylene felt, and the knife passed through by washers and the ultra-high molecular weight polyethylene felt without a problem. So that was a pretty depressing turn of events. Bit of a waste of money and time, or at least that's what it seemed. But I decided to persevere and to glue the washers into 2 layers of the felt. This bonded sample actually reacted to the manual stab tests in a very different way to the loose washers left on ultra-high molecular weight, just scattered on ultra-high molecular weight polyethylene felt. The bonded arrangement appeared to be acting more as a combined system, combining the properties of the shim washers with the ultra-high molecular weight polyethylene felt to yield a far better stab response, which appeared to be more than just the sum of its parts. In addition, because of how thin and flexible the shim washers were, they could be put into an overlapping pattern, reducing weak spots in the armor. It's a little bit like scale armor, while allowing the armor to flex and bend like stiff fabric because the shim washers themselves are quite flexible. Another advantage of using such thin shim washers was that they added very little additional weight to the design. As you'll see later, each stainless steel shim washer weighs approximately 0.5 grams. So half a gram or so, maybe a little bit less than half a gram. The overlapping scale washer arrangement that I used can effectively cover an area of 0.01 square meters with 25 washers. So to cover an area of 1 square meter, you would need approximately 2,500 washers, which would weigh 1.25 kilograms. Now this may sound heavy, but compared to the other options I was considering, it's comparable, if not quite a lot superior. For instance, 2mm thick G10 fiberglass washers covering an area of 1 square meter would weigh around 1 kilogram and would not provide any overlapping protection. If a similar overlapping pattern were used with 2mm thick G10 washers to cover the 1 square meter, the weight would be close to 2 kilograms and it would be extremely bulky and stiff. Now to do the bonding, I used cyanoacrylate adhesive to bond the stainless steel washers onto ultra high molecular weight polyethylene felt, and this seemed to work really well. The bond was excellent. So it was time for me to build and test a sample. I took some video footage of me constructing the test sample, and this is what that looks like. So these are the stainless steel shim washers, 0.1 millimeters thick, quite fragile actually, or apparently quite fragile. You can see by how easily I'm bending it. Obviously I can deform it permanently if I want to. Let's see how much they weigh. So 0.49 grams. So about half a gram each. So quite light. I can cut it easily with a pair of children's craft scissors. So can something as apparently fragile as this help to create a fairly flexible fabric that is stab resistant? Well, I think I can, based on the preliminary tests I've done. So we're going to make a test sample now. I'm going to be layering, just put it into view here a little better. I'm just going to be layering essentially like overlapping scales of these shim washers. Only one shim washer deep, except of course they'll be overlapping. I'm not going to try and stagger the rows or anything. I'm just going to overlap them one above the other, one row above the other. I made this handy dandy little tool, which is just a magnetic, it just contains a bunch of little permanent magnets and helps to hold the washer when I apply the adhesive. For the adhesive, I'm going to be using cyanoacrylate adhesive, like a super glue product. It sets fast and it bonds these washers quite well to the fabric. This is the ultra high molecular weight polyethylene felt, the thicker type of felt, and that's what I'm going to be using. I'm going to be building up one layer of shim washer scales, and then I'm going to be folding it over and bonding it so that there'll be two layers of ultra high molecular weight polyethylene felt and one layer of shim washers in between. So this is really just to show you what the process of construction looks like. So just apply a pressure while I'm constructing it. Only really putting the adhesive onto sections of the stainless steel shim washers that are in contact with the fabric beneath. That's really where I want the bonding to occur. So I'm just applying pressure to get the adhesive to bond quickly. I'm sure the rest of this is going to get really boring for you guys, so I'm actually going to cut the recording now until I've finished putting on these layers of shim washers. Okay, I've done the first row, as you can see, so I thought I'd best just show you how I'm going to overlap the rows. So as I said, I'm just stacking directly one above the other, or one below the other, as the case may be. In this case I started with the top row. And so on. So I've just put the last row of shim washers on. Now what I'm going to do is I'm just going to liberally douse this with cyanoacrylate adhesive, just so that I can close it and be reasonably well bonded together. Doesn't have to be perfect. That should do it. Fold it over and apply pressure, and make sure to glue my fingers to something, as you do. And here it is, the finished product. It's quite flexible, as you can see. Moves, it's a bit stiffer than normal cloth, obviously, but moves quite freely. And it hasn't added much weight at all to the final product. As I said earlier, each of these shim washers is about 0.5 gram, so it really doesn't add much in terms of weight, which is a good thing when it comes to body armor. So we'll test it and see what happens. I then went on to test the sample using my pendulum setup. I tested it side by side with a simple double layer of ultra high molecular weight polyethylene felt for comparison purposes. And this is what those tests looked like. So, welcome to the test, the part of the video where we do some of the testing. This is, of course, my standard pendulum test rig. I've got it loaded with 5 kilograms of weight, and I've got the knife blade mounted onto the side of it here. This, of course, is the GI Tanto blade by Cold Steel, and I've just been using that as a standard in all of my tests. That's just my personal preference. It's a reasonably aggressive stabbing point, Tanto point. It's sharp, and let's put that back on for now. I've got the target. First of all, I've put it as a test sample, just 2 layers of the ultra high molecular weight polyethylene felt. So that's with just 2 layers of it, nothing else. And this is just for comparison purposes, comparative purposes. So we'll see what happens when we test this. So I'm going to start at about 35 degrees, and that's fairly substantial penetration. And just for argument's sake, we'll take that up to 45 degrees and we'll see what that does. And again, fairly substantial penetration. Always practice safe science. So let's take a closer look at the sample. So hopefully you can see that. As you can see, pretty obvious penetrations in both cases through both layers of ultra high molecular weight polyethylene felt. So this is how just 2 layers of ultra high molecular weight polyethylene felt stacks up against that particular test. So we'll go on now and we'll test the scale armor version of this. Okay, so now I've got the targets set up with the ultra high molecular weight polyethylene felt and stainless steel shim washer scale armor, and we'll see how this stands up. So we'll start at 35 degrees again. Okay, there's a small penetration, but nothing like what happened before. Let's go up to 45 degrees and see what happens there. Back on. And we'll have a closer look at the target. So as you can see, there was some penetration, but if you have a look on the back sheet here, the penetration is hardly something that's actually going to be life-threatening. So that would have represented perhaps a centimeter or less of blade actual penetration there. So that's a substantial improvement on the just the plain ultra-high molecular weight polyethylene felt fabric on its own. So we're going to do one final test against the ultra-high molecular weight polyethylene fabric felt and stainless steel shim washer scale armor, and we will up the ante a little bit and see what a destructive test is going to do to it. So I'm going to be going at a going to be using a higher position starting point. We'll go to 55. Take a look at the target. And again, slightly more of a penetration, but it certainly is not penetrating fully. Again, that might be just over a centimeter of blade length that actually penetrated the fabric. Certainly not something that you'd want to happen, but nowhere near as life-threatening as the penetrations on the ultra-high molecular weight polyethylene fabric on its own. So we had to do a post-mortem on the two armor samples that were tested. This is the first test sample that I tested earlier. As you can see, the penetrations are pretty deep, and I have the GI Tanto knife blade here just to show approximately how deep the knife blade penetrated. Now, the only reason that it actually stopped at its point of stopped penetrating at that point was actually because it would have been there that it would have hit the back of the foam pad that I had behind the armor samples to simulate a soft fleshy target. So if it weren't for the fact that it had penetrated all the way through that foam pad, it more than likely would have penetrated fully through this armor sample. So that's pretty serious, but for argument's sake, let's just measure the depth of penetration there. So that is 'just over 4 centimeters deep. So about, actually, sorry, just under 4 centimeters deep. So that's 3.8 centimeters deep on that cut, and that was at a 45-degree angle on the pendulum. So we'll have a look at the second armor sample. This, of course, is the 2 layers of ultra-high molecular weight polyethylene felt with the shim washers in between at 45 degrees. That is the depth of penetration that we got. So that was, I'll set it up and then measure it. This is going to be a little bit awkward. I'm trying to balance a bunch of things here. So that is approximately 1.4 centimeters deep. So that's hardly what I would call life-threatening in any way. Certainly nowhere near as problematic as what would have occurred with just 2 layers of ultra-high molecular weight polyethylene felt, which would have, as I said, were it not for the foam padding, it would have penetrated, the knife blade would have penetrated fully Now at 55 degrees, the result was a little bit worse, but still nowhere close to being life-threatening. And certainly didn't penetrate fully. And this is, again, this is at 55 degrees on the pendulum test setup, so far more energy in that. But for completeness, we'll measure how deep that was. So that was approximately 1.8 centimeters deep. Again, not life-threatening. Well, certainly nowhere near as life-threatening as the full penetration that would have occurred if it was just 2 layers of ultra-high molecular weight polyethylene felt. This is a totally survivable wound. Of course, as with any wound, if you're unlucky, you could just hit an artery close to the surface of the skin if it hits in a bad location, but it's highly unlikely that would have been life-threatening or even do enough damage to take someone out of a self-defense fight. So I'd say this is pretty compelling. Compelling and substantial sort of weight of test evidence to suggest that this is a far superior product and would provide quite a significant amount of protection at very little additional weight and still very flexible, very much like a fabric. Yeah, very interesting results. Now, if you've checked out my other stab test videos, and I encourage you to do so for additional context to this one if you're interested, you will know just how brutal that pendulum test rig is. It's very difficult to build practical armor that will survive that test. However, the ultra-high molecular weight polyethylene felt and stainless steel scale armor pattern performed very well indeed. And this is the test sample after the test. As you can see, there's some penetrations here. You will have seen that being discussed earlier. This arrangement will lend itself quite well to making garments or garment linings that offer reasonable stab resistance. As you can see, it's quite flexible. The one area in which it might actually suffer a little bit more than normal cloth is in compression along its plane. So in this regard, it still does bend and flex, but not as much as you'd expect from normal cloth. But that's a small price to pay. Typically, just in normal flexion and bending, it's quite, as you can see, quite cloth-like. So yeah, that's really all I wanted to say about that. I wanted to put this video out here because there were a few comments about it. And if you have any questions or suggestions, feel free to comment below. I read all my comments. I respond to many of them. But for now, I hope you enjoyed that video, and I'll see you all again next time. Cheers.